We'll now look at what's called inverse variation. We say that y varies inversely as x if y is equal to k over x, where k is once again positive and is still the constant of proportionality, just like it was with direct variation. Therefore, on a single problem, once we find k, it will not change. With direct variation, essentially what is said is as one value increases, the other one will as well. Inversely says the opposite of that. As one value increases, the other will decrease. For our first example, the current varies inversely as the resistance. This is if we're talking about electricity flowing through a wire. The current is 40 amps when resistance is 12 ohms. So what happens if the resistance is 20 ohms? Varies inversely tells us that our current is equal to our constant over the resistance. If our current is 40 amps, the resistance is 12 ohms. Multiplying both sides by 12 gives that 480 is equal to K. Now that we've found K, it will not change for this problem. I want to know what happens when my resistance is 20 ohms. So we can stick that in for R. And dividing gives that we will have a current of 24 amps. For our next example, the time it takes to fly from Los Angeles to New York varies inversely as the speed of the plane. At 900 kilometers per hour, the trip takes 6 hours, so we want to know how long it will take at 800 kilometers per hour. Well, we know it varies inversely. I'll use t to represent time. Should be equal to k over, and this says the speed of the plane, which we'll use an s for. We know that the time is 6 hours when we're going 900 kilometers. Multiplying everything by 900 gives me 5,400 is equal to K. Therefore, I now have my formula. And I can stick in 800 for S. So now I have 5,400 divided by 800, which gives me that it'll take 6.75 hours. That would correspond to 6 hours and 45 minutes. For our last example, your weight varies inversely as the square of your distance from the center of the Earth. In this case, the radius of the Earth is 9,200 miles, and we have a person on the surface that weighs 140 pounds. We want to know how much they weigh if they are 1,800 miles above the Earth. Well, it says it varies inversely, so I'll use W equal to K over, as the square of their distance, so D squared. We know they weigh 140 when their distance from the center is 9,200, since that would be the distance between them and the center of the Earth. Solving this equation gives 1.18 times 10 to the 10th is equal to K. Therefore, I now have my basic formula, 1.18 times 10 to the 10th divided by their distance squared. For this one, this person is not just at 1,800 miles above the Earth, but from the center of the Earth, they're 1,800 plus 9,200. They're 11,000 miles above the Earth now. And then we need to square their distance. Doing this gives us the value of 97.93. So as they move up, they're now weighing 97.93 pounds.